remember, hemoglobin is present, is the characteristics of a, it is a characteristic of aerobic form of life. It means that hemoglobin is present in aerobic life. Aerobic organisms are those organisms which are dependent on oxygen, which are dependent on hemoglobin to carry this oxygen molecule, which required oxygen molecule, aerobic organism. And hemoglobin molecules are not present in anaerobic form of life. Anaerobic are those organisms which do not need oxygen. If they do not need oxygen, there is no need of hemoglobin. So anaerobic organisms do not need hemoglobin. Aerobic organisms need hemoglobin. So make sure you memorize this thing. The other very important sites of hemoglobin synthesis, it is synthesized, it can be synthesized in the spleen, in the liver and bone marrow. Liver and spleens are the site of synthesis and the childhood period of life. And bone marrow, it is synthesis, the bone marrow as the site of synthesis and adult life. So RBC, this is synthesized in two stages. 65% synthesis is done in the reticulocyte stage and 35% synthesis is done in the erythroblast stage. So these or vice versa, if I'm not confusing it. So 65% synthesis is done in one area and 35% synthesis is done in another area of the hemoglobin. So RBC contains this molecule of hemoglobin. RBCs contain molecule of, this is an RBC. It contains hemoglobin. This RBC will go to the lungs for saturation. Saturation is the condition when this RBC attach itself, RBC plus oxygen molecule, it is called saturation. This saturation is done maximum up to 97%. Why up to 97%? Because there are some physiological shunts in the body, some physiological shunts. What do you mean by physiological shunt? Physiological shunts are those shunts which do not allow the passage of RBCs from the lungs, which do not allow the passage of RBC through the lungs. So these areas are called shunts. These small parts are called shunts. So there are normal physiological shunts, normal shunts in the body which do not allow this passage. So if do not allow this passage, so saturation is approximately 97%. And when it goes to the tissue and it gives its molecule of oxygen, so at the same time there is approximately 75% saturation present. It still depends on activity of the body, but whenever this RBC molecule go to the tissue, it gives oxygen there. When it gives oxygen there, and then it comes back to the lung, when it comes back to the lung, at the same time it will be 75% saturation. So by now we know at the level of tissue, the saturation is 97%. At the time of tissue, the saturation will be 75%. Lifespan of RBC molecule is 120 days. After 120 days, what happens to this molecule of RBC? It goes to the spleen and it gets destroyed there. It goes to the spleen and it gets destroyed there. So by now we know that spleen is the graveyard of RBC. Spleen is the graveyard of RBC. Why it is called graveyard? Because the destruction is taking place there. Whenever the RBC goes there and destruction of RBC takes place, whenever RBC goes there, this is an RBC, it goes there and it destroys. So whenever it destroys, the molecule of hemoglobin will be liberated. This molecule of hemoglobin, what is the fate of this molecule of hemoglobin? So hemoglobin, heme will be separated and globin will be separated. This heme molecule we already knew by now. This heme molecule will split up into iron, which will be recycled. This molecule of porphyrin, these molecules of porphyrins will convert into unconjugated bilirubin. Unconjugated bilirubin will go to the liver. This unconjugated bilirubin will be converted into conjugated bilirubin. Conjugation will take place inside the liver, and this conjugated bilirubin will then be excreted to the feces and the urine. So we come to the spleen. The molecule of RBC is destroyed there. Hemoglobin is liberated. Hemoglobin will be split up into two, heme and globin. Heme will goes into two, iron, which will be recycled. Porphyrins will be coming down to form unconjugated bilirubin, which will go to the liver, and then conjugation will be taking place inside the liver. And from the unconjugated bilirubin, you get the conjugated bilirubin. Why we want the unconjugated bilirubin to convert into conjugated bilirubin? Because this unconjugated bilirubin cannot be excreted from the body. So this unconjugation bilirubin will be converted into conjugated bilirubin so that excretion can be taking place. This globin chain will be converted into two alpha chains and two beta chains as in normal adult hemoglobin, and this will be recycled as well. So this is the normal fate of hemoglobin molecule. After the 120 days, the RBC molecule will be splitting up, and these are the normal cycles which will be taking place. Now coming to the synthesis of a molecule of RBC, hemoglobin molecule.